There it is.
Okay.
Okay.
Give him the high sign when you're ready. So, so I was browsing the Sailplane forum on RC groups, and I became aware of this new build thread of this Arcus. And it had some beautiful pictures of this H model, which is a very rare model to find around here. So, as I was following it on a daily basis, I noticed that the builder is actually a local guy. So I contacted him and I said, hey, I love your airplane, and would you be interested in doing a show and tell for our club in the South Bay? And Rick immediately responded that, oh, absolutely, I'd love to do it. So I worked out the schedule with Kyle, and Rick was supposed to be here in October, but I guess something happened last minute, and Kyle asked me to bring Rick here this month. So he hurriedly, he accepted, and he hurriedly put his slides together, presentation together, and again, I want to thank Rick Weber for doing all this stuff for us, and we did a lot of work to get ready. So this is Rick Weber and his Arcus.
Thank you very much. It's really a pleasure to be here. I've actually never been a member of a scale or a model airplane club of any kind. So this is a real honor for me, and really appreciate you guys making some time for me to come in tonight. So a little bit about me before we get started on the airplane. I started flying when I was 12 years old down in Southern California. I lived in Torrance, and I flew off of places like Point Furman, Bluff Cove. There was a place called Three Towers. They were all in the Palos Verdes Peninsula.
Torrey Pines?
I flew at Torrey Pines when I was at school. I went to UC San Diego.
Okay.
Perhaps because of the gliding, I'm not sure. And I brought my little special bonus airplane tonight. So this is the kind of airplane I flew back in the day. This was in the 70s, and I guess we call these things PSS nowadays, pseudo slope scale, but back then we didn't have that name.
Yeah.
And I started designing and building these things almost as soon as I started flying. My first airplane was a Windward, Mark's model's Windward, if anybody remembers that. And I had a Scimitar, which was a flying wing. We made Junior Noblers, which were control line stunt airplanes. There was a junior, it was the Junior, not the full size, and we just converted them to slope. And then I started making my own, and everybody flying out of Bluff and Furman at that time were really into making these little jet models. So I made an F-16, I made an F-14, this one's an F-18. I designed this when I was, I think at the beginning of 9th grade in high school. And I actually started building this one in 1995, many years later, and then kind of stuck it up on a shelf in half-built condition. And about 4 years ago, my son spotted the pieces. And by the way, once I got into college, I kind of gave up RC. Cars and girls were a lot more interesting. Right? So when my son spotted the parts, he's like, Dad, that thing's really cool, so put it together and teach me how to fly. So that's what prompted me to finish this. It was about 4 years ago. And I got back into flying. I taught my son how to fly. We got like another kind of a Windward kind of a model for him to learn how. And he immediately lost interest in, and look what happened to me. So I'm back into the sport now.
That's exactly what happened to me.
So, yeah, let's go ahead and start the slides. So the model is a 1/3 scale model of the Schempp Arcus, which is made in Germany. It's the latest generation of 20-meter racing gliders. They're designed, of course, just like the models for endurance and speed and racing. It's a 20-meter span on the real one. A lot of interesting specifications up here. What I really like are the maximum speed, about 175 miles an hour. I'm going to talk about that again a little bit later. And glide ratio, just stunning, 50-to-1. By the way, I kind of feel like Rip Van Winkle sometimes because, I was out of the hobby for about 20, 25 years. And coming back into it now, you'll see this is a recurring theme. I'm going to touch on it several times tonight. It's just incredible. All this great new technology exemplified even by the full-scale glider. So it's fully molded, it's all carbon fiber, it has amazing statistics, it's got incredible latest generation airfoils, and it's the same with models. Back when I was flying as a kid, there weren't any lipos. there wasn't any carbon fiber. I don't even think it had been invented yet. Kevlar, like for live hinges, that wasn't around either. All the really high tensile strength resins and so forth weren't there. And airfoils, like on the airplane, that stuff I got out the French curve, right? I was just eyeballing it. And I read an interview by Hobie Alter, right, the designer of the famous Hobie Hawk. He said he drew that airfoil around the curve of his shoe. So it's great to come back and see all the technology that's being applied in industry generally, certainly with the full-size aircraft and in our models. It's really great to see. Next slide, please. So this is a model made by, it's a Czech company. It's in the Czech Republic called H Model. It's really kind of a one-man shop as far as I can tell. It's a 1/3 replica of the full scale, which means 6.6 meter span. It's about just an inch or two short of 10 feet in length on the fuselage. The weight on this, mine weighs like right around 38 pounds. They can go up from there depending on what kind of equipment you have. And I should mention too, the full scale aircraft has an option. It could be a pure glider, but they also offer 2 different powered options, which they call up and go, just like with the models, where a motor is retracted above the wings and doors open above the wings in the fuselage, and this big power pod comes out and it's able to power the airplane. And those same kind of power systems are available for our models as well. If you want to spend about $2,000 or $2,500 on them anyway, they're extremely expensive. What I really like about this model is how faithfully it replicates all of the full-scale functions. So it has a total, it's got 4 movable surfaces to correspond to the 4 sections of the wing on each side. They're actually set up as, how is this, two ailerons on the outside and 2 flaps on the inside. Although similar to the full-scale aircraft, I have the radio programmed so that when I can camber the entire trailing edge up or down as I desire. Did someone have a question?
I don't see any control horns. Is that RDS?
Yes, LDS on the inner 2 on the flaps and RDS on the outer 2, which are ailerons, and I'll cover that in the slide.
Oh, okay.
It's also got spoilers, and what I also really find interesting about the airplane is that it has operable water ballast tanks. It's an option when you order the aircraft, but each side holds something like about 5 pounds or so of water. And I ordered the option. I don't actually have it hooked up, but you know, if I ever get involved in GPS racing, where the ballast is an important component of the speed component of the trial, that's something that I can hook up. And just like the full-scale aircraft, you can dump it in flight. And if you look on the internet, there's actually, I should have picked up one of the pictures. Dramatic picture of the airplane with this cool water trail pouring out behind it.
Is that the model or the real one?
Both. Yeah, you can drop it in flight on the model too. Of course, you know, it's got the retractable wheel. It's got a tow hook in the nose, releasable tow hook. I think that's most of it. What I find interesting is each wing, I have to count here, has 4 or 5. I've got 5 servos in each wing, and if I had the water ballast, that would be a 6th servo. So you can have up to 12 servos just in the wings. When you order, there's a bunch of other options available that you can get from H Model. You can get the full interior, scale interior. I ordered that option. You can do what they call a fuselage repaint, which I also ordered, which they sand down the seam line on the top of the fuselage and repaint it so it's perfectly smooth. You can't see a seam on the top. The releasable water ballast, of course, is an option, which I ordered. I did not order the wheel brake. I figure I'll be flying in places where there's plenty of room that goes behind us. Just let it roll. What I also like about the airplane is it's 100% carbon fiber, with the exception of the first 24 inches or so of the nose area, which is made out of fiberglass, and the reason they do that is so that the receivers work properly. Apparently the radio signal doesn't penetrate the carbon fiber very well. Next slide, please. So each model, as I mentioned, they're from the Czech Republic. They manufacture nothing but these very large, high-scale or large-scale gliders, and they're really well known in this kind of scale gliding community as being one of the top manufacturers, which is one thing that attracted me to them. Next slide, please. And some of the other offerings, in addition to the 1/3 scale Arcus, they have a 1/2.5 scale Arcus, which is 8 meters, which can also be used in the up and go portion of the GPS competition, which I'll address a little bit later. They have an ASH-31, which, like the full-scale aircraft, has removable wingtips that are of different lengths, so it can be either a 7.2 or an 8.4 meter configuration. And I just noticed this when I was putting together the slides this week. They just released, or at least have started advertising, a new glider called the Quintus, which is a follow-on glider from Champerth to the Arcus. So just like the full-scale guys are continuing to develop their technology, the modeling guys are as well. And all of these models are totally aimed at GPS triangle events. They're all about competition. Each model and its owner, whose name is Radim Morki, expert aircraft designer, develops his own airfoils, does a lot of simulation, does a lot of testing, and these airplanes are proven in the heat of GPS battle. So they're really representing the leading edge of gliding technology right now. Next slide, please.
So the airfoil on the model is not the same as the airfoil on the full scale?
No, not at all. Not at
Because
all.
it's different rentals on it.
Totally different, yeah. As a matter of fact, if you look on the RC Group's blog that I put together on this, you can, somewhere in the thread, I have a picture of some full-scale airfoils, and it's radically different. They wouldn't work on a model at all there.
It's probably a lot thicker on the full scale.
Yeah, it's a bigger percentage, and the thickness goes much further back to the trailing edge.
Yeah, whereas this is pretty thin.
Yeah.
Is that about it?
They don't advertise what kind of airfoil or the specifications, but it's probably around 10%
That's what I was
fluid
gonna
and maybe 8% or so towards it. So let's roll the video. This explains what GPS triangle racing is. Oh, did you turn out the volume?
Oh, wow.
You might have
Probably.
to.
We could actually get some.
Yeah, no.
Let's move
Pardon
on.
the technical difficulties. I turned off my volume earlier. So, my desktop has disappeared. Okay, is that volume right there? I have to look on the screen. Yep.
Yeah, that's all.
Okay, yeah, well,
Okay.
that's good.
That's strange.
Maybe we can probably still play it.
There it goes. So let me rewind it, and you think you have sound now?
I thought I heard some beeps off the computer. Is it playing right now? It's playing off most of the volume.
Yeah, it seems.
Can you play the onboard? Can you play the onboard?
Yeah, let's try it. Just the computer, see if it's.
Looks like we might miss the first part of this YouTube video.
Just try to point back.
I tried and
It didn't work.
no.
Well, it's not a Mac, that's why.
So
And it's frozen there, okay.
when you get to the URL, we can just put it in the web.
Right, go back.
You can edit the slide and just grab the URL.
Okay. Just want to bring in the browser again. Greatest plan.
Really well.
I think I saw it.
That'd be good.
Because I was scratching my head off.
100%, it's better.
Yeah, that's fine, that's all right, 100%.
Married, Joe. We decided to keep cooking.
Oh, you know what? I don't know. Yeah. Let's, well, hopefully the next video. All right, sorry about that. So we're going to skip that initial YouTube video, and I'll do a brief explanation. Yes?
Is it posted on our series?
Yes. Yes, the videos are all on on RC groups. So the 30-second explanation of GPS triangle racing is that 1/3 scale model gliders, which are not allowed power options, are stuffed full of GPS equipment which measure altitude, position, speed, and so forth. The telemetry is transmitted back to the ground. The pilot is working with a navigator. The navigator is working with a display upon which a virtual triangular course is laid out. And the pilot has to fly around the triangular course as many times as possible in 30 minutes, starting from an initial tow of 500 meters. So obviously they could bomb around the course as fast as they can, but they'll only go around 2 or 3 times before the plane just loses altitude and they'll have to land. So the strategy is to go as fast as you can until you basically need to find a thermal and climb back up. So at some point you need to find a thermal, get as high as you can, some strategy there on how far you want to allow your airplane to climb out, and then bomb around the course again. And it's simply won by whoever goes the furthest, the most number of triangles flown. And I think in some of the recent competitions, some of the winning numbers have been 12 to 14, sometimes 18. They can get a lot of triangles in.
How long is the course?
It's a mile and a half. And the airplanes, when the lift is good, even though they're not diving too much, I've seen on RC groups and some other websites that they're getting well in excess of 100 miles an hour, sometimes up to 120, 130 plus, and that's not even at a very steep dive.
When does the 30 minutes start?
It's
Is it a gate or is it?
I don't know if all the airplanes are started at the same time, or if as soon as the airplane is released at 500 meters, if that starts the time. It could be on a per airplane basis. I haven't done the competition myself.
American cross country, you cross a line, and that's where you.
Like a sailing
source, yeah.
Yeah, I'm not sure on that detail.
Rick, is this the video you can show?
Yeah, you wanna play it?
Might just do it, yeah.
What is it? Oh.
The video they're gonna show.
Total energy compensation.
You can if you want to.
You didn't have it done on this one.
I have the tech tube set up in the tail.
Oh, okay.
I haven't installed it at very honor yet.
Yeah,
Excuse our IT department.
Rick, it's Rick, right?
Yeah.
This thing is like really perfect. It's beautiful. Have you flown it?
No. Not yet. I keep waiting.
He was gonna fly
for
it
tow.
last Saturday at the Aerotow, that the two planes went down. He was gonna have his maiden.
So I had this thing ready in May. It was ready to go in May. Except at the very first Aerotow, which there was an Aerotow in May, the day of I discovered I had a firmware issue with some electronics on board the aircraft. So I had to scrub that day and update the firmware
That's
version.
good, yeah. And you don't fly it until you're ready.
Yeah, and then the next month in June, I think the Aerotow pilot took a month off. I think he was on vacation. And then in July, the Aerotow was during the week when I couldn't make it. And then last month, it was in August. It was on a Saturday, but I had unfortunately too many things scheduled already.
Rick?
So maybe next time.
So there's usually a monthly Aerotow in Visalia, and in particular, usually the middle of October, there is a big Aerotow for 3 days, Friday, Saturday, and Sunday.
Okay.
So you can, and it's a wonderful place to fly.
Good place to
That's on scale.
Great.
They
Thanks. Yeah, I'm
taking off and
we're
landing on grass.
Visalia Club. It's just a long drive.
Yeah.
All right, do we have sound?
Okay, now we don't have sound.
It's all right.
Man, this IT guy.
Okay, well,
he's retired.
we'll worry about that.
Well, you know what? It has subtitles.
Just
You
that
can watch.
one. You can give a voiceover.
I think that might have been an Arcus.
Is this line of sight or by instruments only? You're flying the planes?
It's, the pilot is watching visually, and the navigator is watching
The screen.
an iPad.
So he tells you when to turn.
Right. Yeah, the navigator totally tells you where to go and where to turn. All right.
Yay.
Well done.
It's a back.
Sean. It wasn't working first, was it?
Now they're talking another language.
Yeah. So that guy's the navigator. He's constantly updating the pilot.
It's almost good, see?
I love the sound.
Oh, I love it.
That's an Arcus.
You can do a lot of buzzing in New York.
It's tremendously efficient.
Too bad.
Yeah.
So you have to land in a certain relatively small area And sometimes apparently it can get very hectic when the thermals have all stopped at the same time, all the airplanes are coming in at the same time, they kind of crash into each other sometimes.
Yeah.
By the way, number one on that list, Mano Markey, I think is his name, flies an Arcus. Jeez, flies artwork.
I'll second that. I was about to note that too.
So they're landing in a square area? Is
Yeah.
that part of the thing you're supposed to land in?
Yeah.
Or otherwise
You
you're...
get points deducted if you don't land in the area in the box.
No escape.
Yeah, they don't do the nose stick. No bullseyes.
Stuff it.
So you can, you want to click the right button to get that back on?
It should, I don't know what to do.
I like
Oh, I
that
know.
there's
I thought you
public
knew that.
Wi-Fi here in the fire
Sorry?
station. There's public Wi-Fi here.
Oh, yeah, you want to just start the slide? Yeah, start the slide.
Convenient.
Okay, next slide.
100 cc.
And I've already gone over this, next slide. So I grabbed this off of a manual from one of the popular navigation systems called Sky Navigator. So it gives you a little sense. It's showing you the corner of the triangle. The triangle is actually off to the left, and the corner is the red dot. And the little dotted line is supposed to represent the airplane flying around the outside of the red dot to make the turn, the left turn around that edge of the triangle. And if you notice on the information on the bottom, it looks like it's showing the speed on the lower left, and then it's the Vario next over to the right, and what is that, lift? Yeah, and then altitude next, and so a lot of interesting information.
Is that the same software that you'd use for cross-country racing?
It's very similar.
It looks like it.
Okay, let's go on to the next one. So, why did I choose the Arcus? Well, mostly because I watched a lot of the videos like the one we just saw, and I think they were really exciting airplanes. But like I was mentioning earlier, I'm just really enthralled by the technology that goes into these. When I was in RC the first time around, scale gliders were the boring gliders. I would never have flown a scale glider. They were slow, they were really flexible wings, they didn't have any aerobatic capability, they were really good at thermaling, and they looked beautiful, but I was flying these little guys, which can do all kinds of incredible maneuvers, and I wanted something fast and snappy and very maneuverable, and scale was never there. And I don't know when things changed, but I think GPS racing had a lot to do with it, because for the first time, it really forced the designers of the scale aircraft to step up to the plate in terms of performance. And not only just in terms of brute speed and efficiency, but to really solve a difficult engineering problem, a difficult aerodynamics problem, and that they had to simultaneously solve two polar opposite conditions, in that they have to have a very fast airplane, but yet they have to have an airplane which thermals really well. And usually if you get one, you don't get the other. And they had to step up to the plate and do their simulations, come up with these new generations of airfoils that actually do both. And they seem to have really accomplished that very well.
They also had to look like a scale plane too.
Yeah, remarkable.
Which is really hard too, I imagine.
Yeah. And just as an aside, I don't have any personal data to prove this point, but a lot of the scale guys on the websites seem to tell you that bigger is better, and I'm sure it has to do with Reynolds numbers and so forth. But they really say that these scale aircraft really start coming into their own really at about maybe 5 meters and on up. So it's that kind of 1/3 size seems to be a really good sweet spot for this mixing of super high performance, great aerodynamic abilities, great capabilities, and incredible, detail to very, a lot of scale details, accurate scale details. And I love the fact that it's all made out of carbon. You probably are all familiar with how they make the molds for these fuselages and the wings. They're machine cut with computer controlled cutting machines out of giant solid blocks of aluminum, multiple layers of carbon fiber in there, and they're able to reproduce the airfoils extremely accurately. And like you can see on this airplane, they've got a very, very nicely formed leading edge, mirror finish throughout. There's no wobbles or warps anywhere, and really an almost razor sharp trailing edge. So they're really getting very high quality, accurate, smooth, aerodynamic airfoils and shapes everywhere. So, like I said, I think it's just a great time to be in modeling right now. And another reason I chose the airplane is basically based on its results. The Arcus and one other aircraft, the Untitled, made by a company called Ballast, seem to, to date, they've been the most successful aircraft. And between the two, I was actually, it's kind of on the fence between the two for a while, and I went with the Arcus because I like the way it looks better. And next slide, please. Okay, hit play, and let's keep fingers crossed. Didn't work.
I can probably pull it up real quick.
That's okay. We already saw the airplane flying. It's getting kind of late, so why don't we just keep going? If anyone wants to see that video, that's actually the video that sold me on large scale high performance gliders, period. This one happens to be the Arcus, but it's up on RC Groups. And it's just got some amazing footage from inside the aircraft and great noises and incredible speeds and lots of aerobatics. So it's pretty cool stuff.
So they took the model and put a camera inside.
Yeah, they put a GoPro on the inside. Which, by the way, I've got a GoPro too, and I've already got the mounting system and so forth set up. So I'll be doing the same thing with this one on the first flight. Okay. Can we go on to the next slide? Okay, so how do you get one of these things? Next slide. You can buy directly from, I think there's a couple of different North American distributors. I think iCare RC might be one of them. I chose to order directly from Radim at H-Model. I just sent him an email. I wasn't sure if he could sell to me directly and bypass his distributors, but he was more than happy to. And the reason I did that is because I wanted to have total control over the options and the buildup of the airframe. Not that I'm a control freak. Wait, we're in radio control. Maybe we're all control freaks. And I also, because I'm cheap, I figured it would be a little bit cheaper for me, even with paying shipping. I was comparing prices. I think it ends up being a little bit less if you order directly and pay the shipping yourself, rather than going through one of the distributors, because they take care of that too. It does take some time. I ordered it in February of last year and received it in September. So you order it, you get in line, you wait for a long time. Well, and they're completely built to order. You don't have to pay until it's done. Do you have a question?
Yeah, the 8-meter version of this.
Yeah?
Have you seen one?
Not in person, no.
I can't even imagine.
Yeah.
One more.
This is 6.6, they make an 8.
Dennis Brown, meter and a half. Much of this thing, meter and a half is nothing.
You know what though? I wasn't really seriously considering it, but I did do some research on it, and I looked at some YouTube videos and read everything there was to read about the 8-meter version. And it didn't float my boat. It clearly doesn't have the level of excitement and high performance that the 6.6 meter does. I think this one at least appears much faster in the air, and it definitely has a much better roll rate. It's much more aerobatic. The 8-meter is just a little more lumbering.
And 6.6 has got a winning record.
Yes.
So
it's one of the top models.
Yeah, you go with what wins.
Yeah. And okay, next slide. I think I covered everything. So what you get? This thing got delivered to my doorstep. It's basically in this gargantuan box. about the size of these two tables put together. It was about that big. So about yay square, and about as long as those two tables. Everything was packed away beautifully. Everything came shipping through okay. But you're kind of on your own once you open up that box. There's like 2 or 3 pages of instructions. That's all you get. So you better know what you're doing. And you better be comfortable drilling and drumming through this beautiful carbon fiber airplane, because you don't want to make a mistake. It does come with some hardware. It doesn't come with everything you need, but it comes with some of the basics. And what they do give you is really high quality. What I really like is the 3mm threaded rod, really beefy stuff, and a lot of 3mm clevises. More than enough to do everything on the wing, but not really enough to do everything for the entire airplane, strangely. They also give you a couple of the pull-pull rudder horns, but not really enough to set everything up, and they don't give you a pull-pull cable. They don't give you an elevated push rod. They don't give you enough ball links to set everything up. So it's a little bit strange. They go about halfway there toward using the hardware. But you know, I almost always use all my own stuff anyway. So I used what I liked out of the hardware set and left everything else behind.
Did they make cutouts in the wings for the servos?
Yes, you can see on the bottom of the wing there are circular covers. There's 4 of them. So those are the 4 servo bays, which are all circular, and they have a recessed lip around the edge. And they also give you 2 flat pieces of white gel-coated fiberglass if you want to make your own flat covers like I did. And they also give you another sheet of fiberglass which has molded in hip fairings that can go over your servo arms if you choose to use external linkages, which is basically the recommended way to set things
So
up.
what's a flap cover? I know about like taping over, it's something to cover the gap somehow?
It's literally a flat piece of fiberglass which you have to cut out yourself to put over the hole where the servo goes.
Oh,
the
so
servo
it
band.
So what's holding it on?
RTV.
What's RTV?
It's like silicone rubber.
Oh, so you glue it on.
Yeah, but not permanently.
Oh, yeah.
But again, it's up to you, right? There's no instructions about that stuff. So use whatever you want. Having said that, there are a few really nice things I liked about it. Hanging off each side of the retract, for instance, are 2 really nice, beautiful, beefy aluminum servo mounts, one for the brake and one for the actual retract. There's a similar beautiful aluminum mount on the rear bulkhead, which is between the wings, which is where you mount your rudder servo. And it fit the servo that I used just perfectly. And it's it's very, very strong and beefy, so I like that. But there's like no mounting for most of the other servos. Again, you're on your own. Okay, next slide, please. All right, so what do you really have to do? I won't read this list, but you can kind of get a sense. I've got a bunch of wing items and a couple of radial items. So you can kind of get the sense. I spent most of the time on the wing. I spent a lot of time on the wing. Next slide, please. So, what is LDS? LDS stands for Linear Drive System. Why? What is this? What is this? Okay, so if I decided that if I was going to get this beautiful scale aircraft, and I decided that if I'm excited by high speed, and I want the ultimate in high speed and low drag, and I want a beautiful glider, I don't want any external arms. Now, most people set these gliders up in the way, by default, the instructions tell you to use external arms. But by having hung around in R3 groups for a little time, I was at least vaguely aware that there were systems now available to allow you to put internal drive systems in model airplanes, and that really turned me on. I'd never done anything like that before, and I've made a lot of models, and I wanted to challenge myself. I didn't want to just do the same thing again. So I decided I would do what it takes to put everything on inside of the wing. with nothing on the outside. So after doing a lot of research, I landed on this so-called LDS system, which I use for the two inner surfaces, the two flaps. And it's essentially like a standard control setup with a servo arm and a control horn on the movable surface, except that it's they're very, very small. So I brought along one of the servo arms, which I special ordered from Europe. It's made by a company called Aviogate, and here we are. So I didn't use all of the hardware you'll see in here. It wasn't beefy enough, but I did use the little red anodized servo arm, which is the circular part. So I'll pass that around. And it's made out of aluminum, and it bolts directly onto the output shaft of the servo, and it has an effective radius from the center of the servo output shaft to where your clevis bolts on. It's like 1/8 of an inch. It's really, really tiny. It's really, really tiny. And then I also made my own internal control horns for the flaps out of some carbon fiber sheet I had wound down. And that's, I don't know if you can see it, but that's what it looks like. And this was for one of the two flaps, and this has an effective control moment of maybe 1/4 inch or so. So this was actually built directly into the flap surface, into the trailing edge of the flap, and epoxied in, and I had a little hole drilled on the end where the clevis sits in. So I'll pass that around too. So that's LDS, and like I say, those are on the two inner surfaces, and the reason, it was actually not too difficult in installation there because the wing is still relatively thick, there's plenty of space, and the front edge of the flap, I don't remember the exact measurement, but it's probably over a centimeter. It's still, so there's still some, there's enough beef that you can get a decent control on. However, this is where I met my first challenge. Because the control horn is so short, it's like when you have a clevis hooked on the very bottommost hole on your control horn, and you notice the slop. Your slop is always more when it's hooked on the lower hole rather than a hole at the top, because any tiny slop you have in that system will get magnified. The shorter the moment is at the control horn, the more the slop is magnified. So if and there's lots of places where that slop can come from. It can come from the servo train in the servo. It can come from the servo arm hole where the clevis hooks in being a little bit too big for the clevis pin. Even if you use a ball link, if you ever, I've used lots of ball links. I've never met a ball link that doesn't have at least a little bit of slop in it. And even that little bit of slop would easily show off on this kind of installation. And the other source of slop that I discovered was that when I simply glued on the servo to the upper skin, the access bay is through the bottom, and then the servo, I actually glued it to the upper skin in each servo bay. And even though there's multiple layers of carbon on that upper skin, it's extremely strong. I can squeeze it; it barely moves. But when I did my initial test with hooking up the system and then kind of checking if there was any slop, there was, and it was because the entire that wing surface, the carbon, was flexing just a tiny bit. I couldn't even see it flexing, but I could if I looked very carefully at the servo, I could tell that the servo was moving just a little bit, and it was from flexing the carbon itself. Even though those wings are that inner panel of the wing alone is 10 pounds, so there's a ton of carbon in there, and even then there's a tiny bit of movement. So how did you have a question?
Oh, no, I was just wondering.
So how did I solve all this? Next slide, please. So two things. I used, instead of a plastic servo arm and a regular clevis, I used this Aviogate aluminum servo arm with a really short moment. And it's completely machined. And it uses a 2mm steel pin. And there is zero slop in that steel pin where it goes through that red anodized component. Not only is there no slop to begin with because it's precisely machined, but it's actually held in place with a set screw as well. So it is not going to budge a tiny fraction of an inch. And then I used the special clevis shown in the picture. It's made by MP Jet, and it's I guess it's cast aluminum, and it has a separate 2mm pin, which is held in place by a little circlip. So even though those components weren't designed to work together, I kind of took a chance when I ordered them. I ordered them separately after doing some research and thought they looked interesting, and then discovered, you know what, that MP Jet clevis fits perfectly around that slot in the Aviogate ribbed servo arm. And so it is absolutely airtight. There's no slop there at all. So that took care of the servo arm and slop issue. And of course, I drilled very precise holes in the carbon fiber arm going into the control surface. And then the next point is to keep the servo from rocking back and forth. I made a special plywood mount for it, actually 2 layers of 8-inch plywood glued together to make a 1/4 inch, which goes all the way forward to the main spar of the wing, all the way back to like a, I don't know if it's called a spar, but there's another spar-like component at the very trailing edge, just in front of the flaps. So it touches those two, and it also ties the top skin to the bottom skin. So that makes the servo installation absolutely rock solid, which is very important because those inner flaps in particular they're almost 3 inches. They're about 2.5, 2 3/4 inches, and it's almost 4 feet long. So I do not want those to flutter. I do not want any slop on those. And it ended up with a really rock-tight installation that I'm really happy with. Next please. For the outer 2 surfaces, the wing starts getting very thin. And ironically, even though this is such a huge aircraft, it's like, what is this, 6.6 meters, like 21, 22 feet. And even though some parts of the aircraft have just so much space to work with, it's a cavernous fuselage. But when I got out here, especially to the wingtips, the thickness is maybe 5/8 of an inch. It gets very, very thin. And then toward the trailing edge, it starts getting very, very small. So that the front edge of the aileron is maybe only about 1/4 of an inch. So it's way too small, it's too thin to use an LDS type of setup. So after doing some more research, I went with the so-called Rds System, which stands for Rotary Drive System. I'd never used this before. Again, this wasn't even invented back when I was initially flying gliders. But it's a really simple mechanical idea that the servo rotates a shaft which has a bend on the outside, and that the bent part of the shaft gets inserted into a slot which is built into the aileron. It's a pocket. And this happens to be another component that I ordered from the same company, it's Aviogate in Europe. And it comes with these nice little carbon fiber pockets, which are exactly 3 millimeters on the inside. And so I built in a pocket on the outer aileron. And as it turns out, I wasn't even aware of this when I ordered it, but H model was so kind that they actually make a pre-built-in 3 millimeter pocket on the inner aileron. So I didn't have to make my own pocket there. And the installation was actually really smooth on these. It's a matter of obtaining a correct angle. I think I used 30 degrees off of the perpendicular as recommended by the manufacturer. And it all kind of lined up, and it ended up, I was very happy with the end result. It makes a very tight installation. It's got plenty of control movement, a lot of flexibility. It seems to be a very low friction installation. So it's as good as any traditional type of linkage that I've ever put together. So I'm very happy with it.
How'd you attach the servo?
You can see in the right-hand picture, I purchased a plywood servo frame. They're readily available for many different types of servos, and certainly for this servo, it's the MKS 6625, which is a new generation of the MKS 6125, which has been around for a number of years, and it's very popular for thin-wing glider, aileron, and flap installations.
Actually, please go ahead.
I was gonna ask how, in this case, how does the rod with the bend in it get attached to the output shaft of the servo? What did you explain?
There's two set screws. There's one set screw, which, well, first of all, there's a large aluminum collar, which you can see in the photo on the left.
Okay.
And that a lower set screw on that collar holds the collar to the servo output shaft, and the inside of the collar is splined to meet the splines of the servo shaft. And actually, I think there's not one, but two additional set screws on the upper part of the collar, which bind the output shaft to the collar. And of course, I filed flats onto the output shaft so they wouldn't rotate, and everything's Loctite in place.
It's
I was just about to ask.
Yeah. As a matter of fact, okay, I'll admit something. I used Loctite on the set screws, but because I never want to go back in that wing and change anything, I used, what's that? It's like an aluminum epoxy stuff.
Oh, JB Weld?
It's like, it's JB Weld, but it's better than JB Weld. I forget what other brand is. I found something which had better specifications. And so I actually epoxied on with this metal epoxy stuff that the collar to the output shaft and also the bent rod inside the collar. It's all epoxy.
It's not coming off.
It is not coming off. If there's ever a problem, I'm going to have to throw, take out the servo and throw it all away and buy all the servo probably.
I guess that's not the end of the world, though, because it's a pretty big fix anyway. It's gonna
Yeah,
take
yeah.
time to-
I don't mind. But I don't expect that to ever happen. I've never had a servo go bad. These are all metal gears and stuff. Yeah, they'll last forever. Next slide. Okay, so going along with this low drag thing, I also decided to replace the plastic gap covers with wipers. Okay, what does that mean? All the ailerons and flaps are live hinged. Does everybody know what a live hinge is? Okay.
No, I don't. It's a live hinge.
A live hinge means that there's a piece of flexible fiber, which is usually Kevlar, that's built into either the upper or the lower surface, wherever the hinge surface
It's
is.
a Kevlar hinge.
It's a Kevlar hinge.
Okay.
Yeah. Which allows, again, those things weren't invented back when I initially flew. I mean, it's more incredible technology. It allows the wing to be molded in one piece. Your aileron perfectly matches the airfoil of the rest of the wing. There's no lump, there's no jump. It's perfectly matched, and it's so flexible, it allows a lot of movement. And I love it that when the aileron, if it's top hinged, like this model is, when the aileron moves down, that leading edge of the aileron actually now disappears into the
So
forward part of the
It's a
wing.
curved pocket that it slides in.
Yeah. And for live hinges to work, you can kind of get a sense in the left picture, even though the aileron is deflected in one direction. Even when the aileron is in the neutral position, there's about a 1/16th or an 1/8 of an inch gap. That there has to be a gap there for live hinges to work and for that aileron to fold out into the inside the other skin. And a lot of manufacturers, if they go to the trouble of making live hinges, they'll put in wipers too. Does everybody know what wipers are? Okay. No?
Keep going. I wouldn't know.
All right. Well, you're in the right location, so I'll show you. I shouldn't do this, but I'm going to do it. I'm going to tweak the aileron up. And you notice there's no gap here, right?
Yeah, so I assume it's a curved pocket with a roundish.
Yeah,
So-
and it's made out of epoxy with microballoons, epoxy with a filler. And usually that would be done by the manufacturer.
You
With
made those yourself?
I made them myself, and you can see how I made them using a strip of thin plastic to fold inside the pocket on that left-hand picture.
Use the aileron as the mold, sort of?
Yeah, it's self-molded.
Yeah.
It's self-molded. So you just mix up a bunch of epoxy and filler, and you very carefully scoop it in to that to the plastic which you've made, and then you carefully tuck the plastic inside the upper skin, and you let it dry. And it's great. It's an amazing technique. And now, no matter how the aileron is deflected, it's essentially gapless and drag-free. So I think it's a great invention.
Can I get a hold of you through RC groups, because I'm gonna wanna do that.
Sure.
I have some problematic, tail pieces that the flaps keep popping out. They're tucked in, they keep popping out.
Is
Almost
it,
lost them
so it's a
all.
live hinge? Kind of
It's a live
setup?
hinge, and on the other side, it has a piece of material, I'm gonna guess carbon, whatever it is, that acts kind of like an internal plastic gap cover, but
Okay.
it's tucked inside.
Oh.
Well, that's the wiper.
Oh.
But mine are short and they keep popping out.
Oh.
And when they pop out, it
Yeah, I
renders the
said,
tail useless.
cut them off,
You-
and make
It was
wipers.
the ellipse.
You just have to make them longer.
Mm,
It's pretty easy.
okay.
I know how to do it.
I have their
Okay.
emails.
So I went to all that effort. That alone took like probably a couple of weeks of effort in there. Just because I didn't want a piece of clear plastic hanging off the bottom of my wing that no one would ever see. But that's totally me. Next slide, please. And by the way, if I'm going too fast or too slow, especially, let me know. I don't want to bore anybody. Wing connectors, I wanted to make sure that when my wings were assembled, that connectors would just kind of slide together automatically. And I was kind of surprised to find out that there doesn't really seem to be standard components that are really readily available to do this kind of thing. Maybe there are, and I didn't find them, but I ended up just kind of making my own. And I used these special Sbus connectors made by Rds, and it's kind of a European version of Futaba. And I had to cut them down to size and sand them and cut parts off. They're designed to be they're designed to be manually put together and manually disconnected. So I had to modify them so that it would work in this kind of automatic fashion. And next slide. Big retract, weighs a ton, not a whole lot else going on there. Yeah.
Looks like a GP bike.
It's a beautiful, beautiful piece of machinery. It's it'll never go anywhere. Oh, and I guess while I'm at it, I also, was really impressed in that these retract units for these large gliders actually have functional gas shock absorbers, just like the full-scale ones. And you can see them just a little bit on the right-hand photo. They're pointing almost straight at the camera. But they actually, they're gas struts, just like that might hold up the hood or the hatch on your hatchback. A lot of cars have those.
So does that retract frame bolt into the fuselage?
Yeah, sure does. It bolts into a forward and back bulkhead, which you can kind of see in the picture on the right. And it's interesting because it's really only held in at the front lower edge, which acts as a hinge point. So if you have a hard landing, the entire retract will then rotate around that forward hinge point, and it's the gas struts which give it that that shock absorbing action and keep the wheel down.
McPherson struts.
There we go. Yeah, it's got a real suspension. Next slide, please. All right, so I mentioned Sbus. Does anybody want an explanation of Sbus?
No.
2 minutes.
Quick one.
It's a new way to hook up your servos developed by Futaba in the last 2 or 3 years, something like that. And the idea is that rather than having every servo being individually connected with its own wire to the receiver, you can have one servo that gangs to another servo that gangs to another servo, or you can have just one long cable that all the servos are tied into. So it's a way to hopefully
It's like a daisy chain.
simplify.
or
It's
something.
like a daisy
Yeah,
chain.
or,
Yeah. And
And do you need special radios to drive them or special
special
power
receiver.
supplies?
Special receiver.
Special receiver.
Yeah.
So it's a feature.
And special
The
servos.
power drain is bigger. Like,
No, it's not because of the power drain. It's because it's a protocol. The Sbus is a new protocol.
okay.
So the old protocol was what, PCM, pulse code modulation,
Yeah.
going out to the servos. And Sbus, I don't know what it uses, but it's not PCM, it's Sbus. And there's, I think it's like a TDMA kind of protocol, time division multiple access. So at certain given, so the time domain is divided up into pre-specified boxes, if you will. And then within each box is basically a channel. And within that box, then it tells you the servo position for that channel. So it's channel 1, and then channel 2, and then channel 3, channel N, and then it starts over at channel 1 again. And then going along with that, each servo has a unique address, and you actually have to tell each servo what time slot or what channel to listen to. So there is an additional step required. You have to program your servos now.
But it's kind of like basically a virtual version of the same thing you got going on your receiver. It's
In a way, yeah.
It's still slot 1, slot 2, slot 3,
Yeah.
slot 4, but now it's virtual
Right,
instead of plugging
right.
it in, take it in.
And you can reprogram your servo at any time to be on any slot. And what's more, I found this when I was working on my spoilers. It's great because you can have multiple servos listening to the same slot, and you don't need a Y cable or anything like that. So both of my spoiler servos are listening to channel, whatever it is, X.
I like this.
And they just automatically move together.
It's the next jump. You used to have receivers with dedicated slots.
Right.
This had to be the rudder. This
Yeah.
has to be the other one.
Yeah,
If
yeah.
you don't have it, you're in trouble.
Yeah, it's
Why
all
don't
virtual
you?
now. Same thing on this transmitter, which I won't talk about tonight, but it's a Futaba 14SG, and that too allows you to assign any channel to any function. So your rudder doesn't have to be channel 3 or whatever the default is. You can make it channel 10 or channel 14 or whatever you want. There's only one problem with Sbus, and that's that Futaba, in its infinite wisdom or lack thereof, doesn't make a heavy-duty cable. And can you imagine all the servos in an airplane like this being fed off of a single regular servo cable that's really only designed to handle the current for one servo? I don't think so. I'm not touching that. So this is what I did instead.
Big cables.
Yeah, so next slide.
Okay.
I ordered yet more crap from Europe. Everything. Oh my God, the shipping charges killed me. As did the exchange rate. So this is another Robbie component. It's called the PSS 2018, and it serves the same function that many competing products do. It is a voltage regulator. It allows for dual batteries, so you can have redundant batteries. If one fails, it will automatically keep using the other battery. And it allows for dual receivers, and it monitors the signal quality coming from each receiver, and if one receiver fails or gets interference or for any other reason has poor reception, it will automatically fail over to the other receiver. And I thought that was probably a good idea to have some backup on a missile that weighs 40 pounds.
That part goes, you're screwed.
Yeah, I don't want to see that failure. Hopefully this won't be it. And along with this, this is designed specifically for Sbus. And part of what attracted me to it is that they solved the problem that Futaba created, in that Robbie has put together this really nice heavy-duty cable. Here, I'm going to start with you. We'll pass it around the other way.
Do you have to have the same,
And here's what connectors look like.
you have to have the same battery for, when you plug it, same
The two batteries have to
capacity,
be
same
the- yeah.
voltage, same everything, right?
Yeah.
Otherwise, they might be able to
European.
charge each other or discharge each other.
German colors.
That's the same principle.
Yeah, I suppose that's right. I don't know how the product works internally with that, if it would permit cross-charging.
Probably not.
But the manual does state that they recommend identical batteries. And what's neat about this PSS 2018, in addition to using this heavy-duty cable with special connectors, it actually has 3 different voltage regulators. One voltage regulator for 2 heavy-duty outputs, which you can kind of see on the lower left of the box in the picture. Another separate voltage regulator for the 2 outputs on the upper right, and then a third voltage regulator for the set of PWM outputs, so standard servo outputs, which are on the front of the box, which you can use or not. But if you don't want to be exclusively Sbus, you do have those 8 standard servo outputs to use if you want to. But everything going out those heavy-duty cables, that's all Sbus. And then you can see in the picture on the right, the other part of the system is this thing. It's a special connector which you can just clamp on to the cable. It automatically cuts the insulation, makes contact, and it has a standard servo connector on it. So the interesting thing about this is that these little special connectors, they're made by a company called Emcotech, again in Germany. They come in 2 different flavors. One is Sbus only, so it takes the Sbus signal coming down the cable and sticks it directly off to the servo. So your servo has to be an Sbus servo. It has to know what channel to listen to, etc. But they make another version too, more expensive, which is an Sbus to PWM converter, in which case you can now plug in a standard servo, any servo you want. It doesn't have to be an Sbus servo. But you still have to know, the servo still has to know what channel to listen to, right? So instead of programming the servo, now you program that actual little connector. It has some kind of little logic circuit in there. And so you program it just like you would a servo. And as it turns out, I have a mix of both. So my spoiler servos are Futaba Sbus servos, but all the aileron and flap servos are NKS servos, which are standard and not Sbus. So I use those special converting cable grabbers for the MKS servos.
So we're kind of getting up to our limit on time, so maybe 5-10 minutes more.
Okay, yeah, I think I'm almost done.
We got a little late start. Okay, next slide.
Yes, please. What I like about it is that it makes a really clean install. It's the TSS 2018. It's got 4 wires coming out of it and the 2 battery inputs on the right-hand side. And you can see on the middle picture that it leaves the majority of the forward fuselage totally empty. So there's no messy cabling anywhere. And the only cabling I do have, you can see on the right-hand side of the picture, I have 2 cables going out to each wing, and that's about it. And I bought this flexible tubing down at Pet Boys to just make it look pretty. That's the only cheap thing in the entire airplane.
You could afford that.
Next slide.
Not priced in euros.
So I won't go into detail, but I tried to use the best possible preset when I programmed my Futaba 14-channel transmitter. They didn't quite have a preset which matched what I needed, but the 14SG has a number of manual mixes that you can program yourself. So by hook or by crook, I was able to get everything set up correctly. And I used H model's recommendation for 3 different conditions. So this is where I think the GPS racing and heritage and all of that is coming in, because Radim, again, the owner of H model, who's also very active in GPS racing, has gone through a couple of different versions of recommendations of exactly how much control throw to use on each flap, on each aileron, how much up, how much down, and also preset camber on the trailing edge. So for what he calls thermic mode, which is like a thermal mode, he actually specifies exactly how much each aileron and how much flap should droop, and it ends up being it's like a millimeter even at the inside. It's just a tiny little preset. But that gives a little additional camber to the airfoil. It'll slow the airplane down and generate some additional lift, so that's useful for the thermal part of the GPS racing. And then for almost everything else, Radim recommends normal setting, so no camber, the neutral trailing edge. He actually, this is interesting, I asked him if reverse cambering the edge, in other words, a little bit of reflex up, even a tiny bit, if that would increase speed. Because if you look at the airfoil, there is a tiny bit of, I don't know if to call it under camber or what, but a tiny bit of camber, right, at the trailing edge. It's like in the last half inch. But if you look at the ailerons and flaps really carefully, you can see just that tiny bit of droop at the very end. So I thought, maybe you can neutralize that by raising the entire trailing edge by, just a millimeter or so to go faster, if that would make it go faster. And Radim replied by email right away. He's already been there, done that. He tested it, he simulated it, and verified that he said it doesn't make any difference with top speed. But he said it helps for flying inverted. So I do. So that's my speed setting. The trailing edge flipped up a little bit, reflexed a little bit. So I'll try it out when I fly inverted and see how that works. Next slide. I've also got snap flap programmed in. Again, this is interesting. Radim, he supplies like 2 pages of directions to build the damn thing. He has like 5 pages of directions on how to program the radio. So I think it's interesting where he puts his emphasis. But I think it's good because that's all that information is gleaned from GPS competitions. So he recommends unidirectional snap flap, and what I mean by that is only when you give up elevator do you get drooping of the trailing edge. So that kind of snap flap. When you give down elevator, there's no corresponding reflex. So you only get that snap flap when you pull back. So you get a little extra lift. In addition, I've got a slider on the radio which I can use to change the camber at any time I want to, and I can actually droop the flaps way down in addition to that preset Turnic mode. And I've got my spoilers on the throttle, and I guess the only other thing I want to point out is that although I haven't seen a published top speed on this aircraft, I'd be willing to bet good money that it has a higher actual top speed than the full-scale aircraft does. I think this thing is good for about 200 miles an hour if you dive it blowing it far enough. Which I think is pretty damn incredible. I love that. Next slide, please. Next step, fly it. I need an arrow tow. Maybe this month will be the magic month. I'll make some videos, and at some point, I've got the variometer tube installed there on the vertical. So I will install a variometer at some point, especially if I get involved in competitions or really serious about thermal chasing. But for now, I intend to fly it at the slope primarily, at least at the beginning. So it's not so important for right now. And then if we ever get some GPS events going here in the States, then maybe I'll put in some GPS and go out and compete with this monster. So let's see.
Cross country.
We do have cross country, so.
Yeah. All right, I'll be in touch. All right.
Montague, perfect.
All right. That's all I got. Thanks a lot, everybody.
Thank you.
So, Rick, aerotow is the only way to bring it up in the air besides launching it off a cliff by hand?
That I launch off a cliff by hand. Can you hold 40 pounds with one hand and throw it 30 to 40 miles an hour? Because I don't think I can.
You can, but
Somebody else will.
Now,
I've launched 6.25 meter
Really?
XW22.
We have a friend, you need a
When
friend.
it's blowing,
Someone who you really trust.
when it's blowing 20 miles or so, it carries its own weight. Literally, you can let go of it and it just goes up.
I'm not there yet.
Yeah,
I'm going to start with aerotow.
I'm not saying you should, but